Okay, let's get into it. Number 10. The Little Green Men. It's the autumn of 1967, and a young graduate student named Jocelyn Bell is standing in a field outside Cambridge, looking at a radio telescope she helped build with her own hands. Not a gleaming dish. Think more like a couple of acres of wooden posts and wire, strung together across an old field. It looks like a failed hop farm. But it works, and every day it prints out the sky as a long ribbon of ink on a rolling chart recorder. 30 meters of paper a day, squiggling out in red pen. Belle is the one who reads it. All of it. By eye. And one night she notices something she calls, in her own words, a bit of scruff. A little patch of signal that doesn't look like a star, doesn't look like the usual interference from passing cars and bad electronics. It's just off. So she does what good scientists do. She goes back and looks at the same patch of sky again. And again. And here's where it gets strange. The scruff comes back. And when they finally get the recorder running fast enough to see it properly, the signal resolves into something that should not be there. A pulse. Then another pulse. Then another. Perfectly. Impossibly even. 1 every 1.337 seconds. Tick, tick, tick. Steady to about 1 part in a million. Now you have to understand what that felt like in 1967. Nature is messy. Stars flicker. They flare. They wobble. But they don't keep time like a Swiss watch. The only things anyone knew of that ticked that precisely were things we built. Clocks. Beacons. Transmitters. So the thought arrives, quietly, and nobody wants to say it out loud. What if someone is sending this? They half-jokingly labeled the source, LGM-1. LGM. Little Green Men. Bell later admitted it was mostly because she was tired of saying, you know that funny pulsing thing at Right Ascension 1919. But underneath the joke was a real, cold question. She was a young researcher trying to finish a PhD, and there was a genuine possibility sitting on her desk that she had picked up a message from another civilization. And then, she did the thing that actually makes her one of the great scientists of the century. She kept working. And a few weeks later, on the other side of the sky, in a completely different direction, she found a second one. A second perfect pulse. Different rhythm. Same impossible precision. And that, weirdly, is what killed the alien idea. Because two separate civilizations, on opposite sides of the sky, both beaming us metronomes at the same time, that's absurd. If you find one, maybe it's a message. If you find two, it's physics. What she'd actually found was the first pulsar. A neutron star. The collapsed core of a dead sun. A city-sized ball, so dense a teaspoon of it would weigh as much as a mountain. Spinning hundreds of times. Sweeping a beam of radio light past the Earth like a lighthouse. Every sweep, a tick. It launched a whole new field of astronomy. It won a Nobel Prize, which went to her supervisor, not to her, a slight that people are still annoyed about, and rightly so. But here's the thing I keep coming back to. For a few weeks in 1967, some of the smartest people on Earth genuinely held the possibility in their hands. Not a tabloid. Not a hoax. A real, careful professional, maybe. And they sat with it quietly, in a cold field, reading the sky off a roll of paper by hand. And for one quiet moment, the universe looked like it might be trying to say something. Number 9. The signal from an empty sky. You've probably run this without ever thinking about it. Sometime in the early 2000s, a lot of us downloaded a little program called SETI at home. It turned your computer, while you weren't using it, into one tiny piece of the largest search for alien life ever attempted. Your screensaver was quietly chewing through radio data from the Arecibo telescope in Puerto Rico, looking for a needle in a cosmic haystack. Millions of people did it. It was, in a way, the whole planet listening at once. And in March of 2003, it found something. The candidate got a name that only an astronomer could love, SHGB 02 plus 14A. It was picked out of the noise by ordinary volunteers, one in Germany, one in Wisconsin, running the software on home machines. It was spotted 3 times, and it sat right around 1420 megahertz, which is a very specific number to land on, because 1420 megahertz is the hum of hydrogen. It's the frequency that neutral hydrogen, the most common stuff in the universe, naturally sings at. And for decades, people who think about these things have argued that if you wanted to signal across the galaxy, that's exactly where you'd do it. It's a landmark, a frequency any technological species would know about, because it's written into the chemistry of the cosmos. They call the quiet band near it the water hole, a natural meeting place. So a signal near the water hole found by the whole world's computers at once. In September of 2004, New Scientist ran it as the best candidate SETI at home had ever seen. And for a moment, the internet did what the internet does. But here's the part that makes the back of your neck prickle. When they looked at where it was coming from, they pointed to a patch of sky between the constellations Pisces and Aries. And in that direction, as far as anyone could tell, there was nothing. No star within about 1,000 light years. Just empty black. A signal from a place with nothing to send it. Now, the scientists themselves were never that excited, and it's worth being honest about that. The man who ran the Berkeley search basically said the press got carried away, that a reporter had misunderstood how the whole thing worked. And there was a genuinely weird feature in the data. The signal's frequency drifted, fast. Tens of hertz every second. That's hard to square with a real transmitter sitting on a real planet far away. It smelled, to careful ears, like an artifact. A ghost in the math. It never came back convincingly. It quietly faded off the list of things worth worrying about. But I love it anyway, because of the picture it paints. The entire species, half asleep, screensavers glowing in a million dark rooms. And out of all that listening, one blip from a corner of the sky where there was supposed to be no one home. Number 8, the Lorimer Burst. In 2007, an astronomer named Duncan Lorimer handed a student a boring job. Go through some old data. 6 years old, from the Parkes telescope in Australia, just sitting in an archive. Nothing anyone expected to find anything in. The kind of task you give a student partly so they learn the software. And the student, David Narkovich, found a monster. Buried in the recording from the 24th of July, 2001, was a single burst of radio energy. It lasted less than 5 milliseconds. Blink your eye, and you'd miss it 100 times over. And in that sliver of time, it was so bright, so violently loud in the radio, that when Lorimer saw it, his first instinct, the correct scientific instinct, was that it had to be fake. A glitch. Something wrong with the instrument. Nothing real should look like that. But it had a fingerprint. When a radio signal travels across the universe, it drags through the thin fog of particles floating in intergalactic space, and that fog smears the signal out. The high frequencies arrive just a hair before the low ones. The more space it's crossed, the bigger the smear. And this burst had an enormous smear. Far too much to have come from inside our own galaxy, which meant the thing was not a glitch in a machine in Australia. It was real, and it had come from billions of light years away. Sit with the energy budget of that for a second. In under 5 milliseconds, that single burst released roughly as much energy as our sun pours out in days. All of it, dumped into a flash shorter than a hummingbird's wing beat, and still bright enough to cross most of the observable universe, and register on a dish in the Australian outback. Nobody knew what it was. Nobody had a name for it. The term we use now, fast radio burst, didn't even get coined until years later. For a while it was just the Lorimer Burst, This one impossible flash that some people quietly suspected wasn't astrophysics at all. And the reason it belongs on this list isn't that anyone proved it was aliens. It's that, for a real stretch of time, we had no natural explanation that fit. A single, ultra-brief, ultra-powerful, precisely shaped pulse from the deep universe is exactly the kind of thing that makes a careful person's mind wander to uncomfortable places, even as they refuse to say it in a paper. We've since found hundreds more of these bursts. We'll get to a couple of them. Most now point towards something natural and extreme. We'll come back to what. But the first one arrived alone, unexplained, out of an archive nobody was even really searching. A flash from 6 years earlier, waiting patiently in a hard drive for someone to notice the universe had screamed once and gone quiet. Number 7. The signal from Hercules. Here's how you accidentally start a worldwide alien panic. There's a star called HD 164595. It sits about 95 light-years away in the constellation Hercules, and it is, frankly, the kind of star that makes you sit up. It's a near twin of our own sun. Same type, similar age, and it has at least one planet. If you were writing a list of good places to point a telescope and whisper, "Anyone home?" this star would be on it. On the 15th of May, 2015, a team of Russian astronomers using a telescope called Rayton 600 caught a signal from that direction, a blip at 11 gigahertz. Strong, about 3/4 of a Jansky, which for this kind of work is loud. It lasted about 2 seconds, and then it was gone. Now, the responsible thing to do with a 2-second, one-time, one-telescope signal is to say nothing and quietly try to catch it again before you breathe a word to anyone. That is the correct scientific process. That is not what happened. Instead, in August of 2016, more than a year later, word of the signal leaked. Somebody circulated it, and the phrase attached to it was, roughly, a strong signal in the direction of a sun-like star. And the internet did the rest. Within a day, it was everywhere. Aliens in Hercules. A civilization 95 light-years away. The scramble was instant and global. The real SETI scientists, the people who do this for a living, dropped what they were doing and pointed their instruments at Hercules. The Allen Telescope Array in California swung over. Breakthrough Listen put the giant green bank dish on it. They stared at that star for hours, across a huge range of frequencies. And they heard nothing. Flat, empty, ordinary nothing. Seth Shostak at the CD Institute, who has the patience of a saint, basically said, "Look, this is not the announcement of the century. One detection, one telescope, one time, never repeated. That's not a discovery. That's a question mark. The best guess now is boring and human. Terrestrial interference. Possibly a stray reflection off an old military satellite. Our own noise, bouncing back at us, wearing the mask of a message. But here's the thing that stays with me. It wasn't a hoax. There really was a signal. Real astronomers at a real observatory recorded a real blip of energy from the direction of a real sun-like star. Everything about it was true, except, almost certainly, the part we most wanted to be true. And the whole episode is a small, perfect lesson in how badly we want to hear something. How the moment a plausible whisper comes from the right kind of star, the entire species leans in at once. Number 6. The Visitor Called. 1991. VG. Not every Eerie signal is a radio wave. Sometimes it's a glint of light off something that shouldn't be shaped the way it's shaped. In November of 1991, an astronomer named Jim Scotty, working with a survey telescope called Spacewatch on Kitt Peak, spotted a small object coming in toward Earth, about 10 meters across. Tiny, as space rocks go. But two things about it were strange enough that people paid close attention. The first was its orbit. Most asteroids are on paths that make it obvious they're just leftover rubble from the asteroid belt, thrown around over billions of years. This thing was on an orbit almost eerily similar to Earth's own. It was practically pacing us around the sun. That's unusual. That's the kind of orbit you'd pick if you wanted to quietly hang around near a planet without drawing attention. The second thing was the light. As it tumbled, it didn't fade and brighten smoothly the way a lumpy rock does. It flashed. Sharp, rapid spikes of brightness, there and gone. The kind of glint you get off a flat, polished surface, catching the sun at just the right angle. Like sunlight bouncing off a spinning panel. And this is where it gets genuinely interesting, because a credentialed astronomer, Duncan Steele, actually wrote about it. In a peer-reviewed journal in 1995, he laid out the possibilities for what this object could be, and he did not flinch from the strange one. He noted the strong, rapid brightness variations, which can be interpreted as transient specular reflections from the surfaces of a rotating spacecraft. Read that again. A professional astronomer, in print, using the word spacecraft. Not on a podcast, not for clicks, in the literature. Now, to his enormous credit, Steele was careful. He said plainly that he did not personally think it was extraterrestrial. His actual point was subtler and, honestly, more interesting. That we should at least take seriously the idea that alien artifacts could exist somewhere in our solar system, and that we should have the intellectual honesty to check before assuming, even if he strongly doubted this particular one was it. And 1991 VG gave us the perfect test, because objects on well-measured orbits are predictable. Scotty and his colleagues said, it'll come back, and it'll be right here in 2017. 2017 came, and it showed up, right on schedule, exactly where the math said it would be. When we got a proper look this time, with better instruments, the verdict was clear. Just a rock. A small, natural, tumbling rock. Possibly even a chunk knocked off the moon a long time ago. The flashing was just sunlight on an irregular, shiny surface. No panels. No probe. No pilot. But I think there's something almost admirable in the whole story. For 26 years, a genuine astronomer's speculation hung over a little flashing object on a suspiciously friendly orbit. And the reason we know it's just a rock is not that we scoffed and looked away. It's that we watched. We predicted. We waited. And we checked. That's the difference between a conspiracy and a science. The willingness to say, probably a rock, but let's make it prove it. Number 5. The burst that came back. Remember the Lorimer Burst? That single, impossible flash from the deep universe. Gone in 5 milliseconds. Never to repeat? For years, that was the whole personality of these fast radio bursts. They flashed once. They died. Whatever made them, we assumed, must have destroyed itself in the process. 2 neutron stars slamming together. A star collapsing. Some one-time cosmic catastrophe. A death cry. Then, in November of 2012, the Arecibo telescope caught another one. Cataloged as FRB1 21102. And at first, it was just another entry on the list, until it did the thing that no fast radio burst was supposed to do. It came back. The same source, in the same spot of sky, flashed again. And then again. Over months, over years, this thing kept firing off bursts. It became the first repeating fast radio burst ever found, and that single fact detonated everything we thought we understood. Because repetition changes the whole story. If the source flashes over and over, then it is not destroying itself. Whatever is out there survives each blast, recharges, and does it again. You can't explain a repeater with a one-time collision or a final collapse. Something is sitting out there, intact, deliberately or not, sending pulse after pulse into the dark. And I want you to notice how uncomfortably close that gets to the shape of a beacon. a signal that repeats, a source that persists, a thing that keeps talking. That is precisely the behavior we would look for if we were hunting for someone. So where is it? In 2017, they finally pinned it down, and the answer was its own kind of strange. The bursts were coming from a tiny, dim dwarf galaxy about 3 billion light-years away. Not a grand spiral like ours. A small, faint smudge of a galaxy, chemically primitive, the kind of place nobody expected to be screaming across the universe. Now, I'll be straight with you, because this channel doesn't do cheap. The leading explanation today is not aliens. It's a magnetar, a young neutron star with a magnetic field so violent it defies imagination, a field so strong it would scramble the atoms in your body from halfway across a solar system. When one of those twitches, it can belch out exactly this kind of burst. And we've since caught a magnetar in our own galaxy doing precisely that, which was, frankly, a beautiful piece of detective work. But here's the thing. Knowing it's probably a magnetar doesn't entirely dissolve the unease, because the honest position is that we're still not certain we've explained all of them. We have a whole zoo of these bursts now, some repeating, some not, and the full picture is still being assembled. And for a while, a real extended while, the best minds in radio astronomy were staring at a source 3 billion light-years away that just would not stop talking, and quietly wondering what exactly they were listening to. Number 4. The flicker at the center of the galaxy. Turn your telescope toward the middle of the Milky Way. It's a crowded, violent place. Millions of stars packed tight, gas clouds, and a supermassive black hole 4 million times the mass of the Sun sitting at the very center of it all. It is the last place you'd expect to notice one small, well-behaved little point of light misbehaving. But starting in early 2020, the Australian SKA Pathfinder, a field of radio dishes in the outback, noticed exactly that. A single radio source, about 4 degrees off the galactic center, that did something none of its neighbors did. It blinked. Not like a pulsar, which ticks away in a steady, machine gun rhythm you can set a clock by. This thing had no rhythm at all. It would switch on, glow in the radio for days or weeks, and then simply vanish. Gone for months. And then, with no warning and no discernible pattern, it would switch back on again. On, off, on, off. On a schedule that fit no known clock. It got the name ASCAP J1736. I'll spare you the full string of numbers. The people who study it just call it a galactic center radio transient, which is a polite scientific way of saying, we found a thing near the middle of the galaxy, and we genuinely do not know what it is. And they've really tried. They looked to see if it was a faint, cool star flaring. The numbers don't quite work. A pulsar with its pulses smeared out by the gas between us and it. Doesn't fit. A magnetar. One of those violent neutron stars from the last item. Closest guess, maybe, but still not clean. Every box they try to put it in, some feature pokes back out. The signal has other odd fingerprints, too. It's extremely polarized. The radio waves are lined up in a very particular, organized way, which usually means strong magnetic fields are involved, and its brightness and character shift around in ways that keep resisting a tidy story. I want to be careful here, because I don't want to oversell it. Nobody serious is claiming this is a message. The smart money is on some exotic natural object, a weird magnetar, a new flavor of transient, something at the extreme edge of what neutron stars can do. This is a genuine open mystery, not a claim signal. But that's kind of the point of putting it here. Most of the things on this list have been solved. The pulsar, the Venus signal, the Proxima whisper we're about to get to. The file gets closed. This one is still open. Right now, tonight, near the heart of our own galaxy, there's a source of radio light switching itself on and off, and the best astronomers we have cannot tell you with confidence what it is. The universe left a light flickering, and we still don't know whose hand is on the switch. Number 3. The whisper from Proxima Centauri. If you were going to bet on where we'd first hear from someone, you'd bet close. And it doesn't get closer than Proxima Centauri. It's the nearest star to our sun, a small, dim red dwarf, just over 4 light years away. Practically next door, in cosmic terms. And here's the kicker. It has a planet in its habitable zone, a world called Proxima b, sitting at the right distance for liquid water, the single most tantalizing address in the entire sky. So when Breakthrough Listen, the $100 million search for alien signals funded by a billionaire, pointed the Parkes telescope at Proxima Centauri in the spring of 2019, they were aiming at the best target we have. And they caught something. It was a narrowband radio signal, sitting at about 982 megahertz. And narrowband matters a lot. Nature is sloppy. Natural sources smear their energy across wide bands of frequency. A signal squeezed into a razor-thin slice like this is the signature we most associate with technology, with a transmitter, with intent. It was so promising it got a name that deliberately echoed the most famous seedy signal of all time. They called it BLC-1, Breakthrough Listen Candidate 1. But nobody noticed it at first. It sat in the archive. It wasn't until October of 2020 that a student named Shane Smith, combing back through the old Proxima data, pulled it out of the pile and realized what he might be looking at. A narrowband signal from the nearest star. That has a habitable planet, and it got better, or worse, depending on how you feel about hope. The signal appeared in several of the observations pointed at Proxima. It drifted in frequency in a smooth way, roughly the kind of drift you'd expect from a transmitter on a moving, spinning planet. Every box you'd want a real alien signal to check, this one seemed, at first, to check. For months, the team could not rule it out. Think about that. For months, some of the most careful people in the field held a signal from the doorstep of the nearest star, and could not honestly tell you it wasn't a technosignature. That is the closest modern science has come to the edge of that cliff. And then they did the work. And the answer, when it came, was quietly devastating. BLC-1 wasn't from Proxima. It was us. When they dug into it, they found the signal was what's called an intermodulation product, a kind of ghost created when ordinary human electronics interfere with each other, producing a false tone that happened to fall at just the right frequency and drift in just the right way to imitate a message. Some clock, some device, some scrap of our own technological noise, mixing together into a near-perfect forgery of first contact. And it lined up with the observing schedule in a way no real signal from Proxima ever would. There was no one on the line. It was our own reflection, calling back. And I think that's the deepest lesson buried in this whole subject. Our machines are so noisy now, our planet's so loud with our own transmissions, that the hardest part of listening for someone else isn't the distance. It's separating their voice from the sound of ourselves. We aimed at the nearest star. We heard a whisper, and it turned out to be an echo of the room we were standing in. Number 2. The Phosphine on Venus. Everything so far has been far away. Light years. Billions of light years. A whisper from the next star over was as close as we got. Now I want to bring it right into our own house. Venus is the planet next door, and it is, by any sane measure, hell. The surface is hot enough to melt lead. The air pressure would crush you like a submarine imploding. It rains sulfuric acid. If you were making a list of the worst places in the solar system to look for life, Venus would be near the top. We mostly wrote it off decades ago. So in September of 2020, when a team led by Jane Greaves at Cardiff University announced what they'd found in the clouds of Venus, it landed like a bomb. Phosphine. Phosphine is a small, simple, extremely nasty molecule. One phosphorus atom, 3 hydrogens. It stinks. It's toxic. And here's why it mattered. On a rocky planet, phosphine is supposed to be a biosignature, meaning, as far as we understand chemistry, there is almost no way to make it in large amounts without life. On Earth, phosphine is produced by microbes, by living things doing their metabolism in oxygen-starved places. Ordinary geology and sunlight make almost none. So if you find a good whiff of it on a rocky world, the boring explanations run out fast. And they found about 20 parts per billion of it, high up in the Venusian cloud decks. The team, including an MIT scientist named Clara Sousa Silva, who had spent basically her whole career studying this one stinky molecule, went through the possibilities one by one. Volcanoes? Not enough. Lightning? Not enough. Sunlight-driven chemistry? Not even close. They kept coming up short. And they were left staring at a conclusion that they clearly found almost too heavy to say out loud. That among the scenarios they could not rule out was the presence of life. And now, the detail that turns this from a headline into something that genuinely gets under your skin. Where is the phosphine? Not on that lead-melting surface. It's up in the clouds. And there's a specific altitude in Venus's atmosphere, maybe 50 kilometers up, where the crushing pressure eases and the hellish temperature drops to something almost mild, almost Earth-like. If anything is alive on Venus, it's not on the ground. It's floating, permanently airborne, in droplets of acid, in the one thin layer of the planet that isn't actively trying to kill it. Now, I promised you honesty. The phosphine claim got hammered. Other scientists went back through the data and argued the signal was weaker than reported, or wasn't phosphine at all, but sulfur dioxide masquerading as it. The detection is disputed, unconfirmed, and genuinely contested to this day. You should not walk away from this thinking we found life on Venus. We didn't. We found an argument. But what an argument. For the first time in most of our lives, serious scientists at serious institutions published a paper that said, "There is something in the air of the planet next door that we cannot explain, and one of the explanations on the table is that we are not alone in our own solar system, not light years away, right there, close enough to see with your naked eye in the evening sky tonight." Number 1. The breath of a distant world. Everything on this list has been, in some sense, a message, a pulse, a burst, a blip, a whisper, energy that came at us and made us wonder who sent it. But the last one is different. The last one isn't a message at all. It's a breath. There's a world called K2, 18b. It's about 124 light years away, orbiting a small red star. And it's a strange kind of planet, bigger than Earth, smaller than Neptune. For a while, there's been an idea that worlds like this might be what some scientists call Hycean planets, covered in a deep global ocean, wrapped in a thick hydrogen atmosphere, an entire planet-sized sea under an alien sky. Now here's how you even study the air of a world that far away, because it's one of the most beautiful tricks in all of science. You wait for the planet to pass in front of its star, and as the starlight streams past, a tiny fraction of it filters through the planet's atmosphere on its way to us. And the gases in that atmosphere each drink up their own specific colors of light, leaving thin dark gaps in the spectrum. A barcode. Read the barcode, and you can tell what the air is made of across 124 light years of empty space without ever going there. We are, in the most literal sense, smelling a planet from across the galaxy. And in 2023, and then more strongly in 2025, a team led by the Cambridge astrophysicist Niku Madhusudan used the James Webb Space Telescope to read the air of K2, 18b, and found a hint of something that stopped everyone cold: dimethyl sulfide. On Earth, dimethyl sulfide has one main source: life. Specifically, it pours off the ocean, made by blooms of marine plankton. Trillions of tiny living things, breathing. That smell you get at the seaside, that sharp tang of the ocean, a lot of that is dimethyl sulfide. It is, on our planet, the exhalation of life itself. And there is no well-understood way to make much of it without something alive. And the signal on K2, 18b, if it's real, suggested there was a lot of it. Possibly thousands of times more than in Earth's air. An entire ocean world, potentially, breathing out the same molecule our own seas breathe out. And Webb, floating 1,000,000 miles from Earth, catching the faintest trace of that breath in a sliver of filtered starlight. I have to hold the line here, because it matters, and because you deserve the truth over the fairy tale. This is not confirmed. The signal is faint. Below the threshold, scientists demand before they'll call anything a discovery. Other teams have gone back through the same Webb data and come away unconvinced, saying the evidence for dimethyl sulfide just isn't solid enough. And we've since learned the molecule can turn up in places with no life at all, like comets, which means our one clean assumption, that only life makes it, is shakier than we'd like. The case is open. The jury is out. But step back and feel the shape of where we've arrived. We started this list in a cold English field in 1967, with a young woman reading pulses off a roll of paper, wondering if little green men were ticking at her. And we end here with a telescope beyond the moon, reading the barcode of starlight bent through the sky of an ocean world 124 light-years away, searching that light for the faint chemical signature of something exhaling. Because that's the quiet revolution hiding in this whole story. For all of human history, we imagined first contact as a message, a voice, a signal, deliberately sent, meaning we are here. But it may not come that way at all. It may not be a broadcast. It may be a breath. Some distant, oblivious ocean full of living things, exhaling into its own sky, never knowing that 124 light-years away, on a small blue world, someone finally learned how to smell it. We've spent this whole time listening for a knock on the door. We might, in the end, find them the way you find a neighbor you never knew was there. Not by a message, but by catching, on the wind, the faint sign that somewhere out there, something is breathing. Thank you for watching and sticking till the end. We've got plenty more videos coming in the future. Hit that subscribe button so you don't miss them. See you in the next one.